We are here today with Miss Gibson's 5th grade class, and we're going to meet with Beyond PLA, Advancing 3D Printing to Additive Manufacturing with Chris Williams. So Chris, take it away.
Hey everybody, how's it going? I'm Chris Williams. I'm a professor in the Department of Mechanical Engineering at Virginia Tech. Let me start by asking, has anyone ever seen or heard of or maybe even used a 3D printer? We're in one room of the lab and it's got lots of different machines and robots and 3D printed parts. We're in a lab called the Dreams Lab and we study 3D printing. That's what we do. So a 3D printer, probably ones you've seen sort of look like these boxes over here. And maybe when you open them up, you might see inside a friendly face, a 3D printed hokey bird. And the way that this is made is we take a computer model of the hokey bird first, and I'll try to zoom in here and see if you can see these little lines on its head. We take that computer model and we virtually slice it into layers. So it's imagine it's taking a stack of paper and stacking it one by one to create a three-dimensional model. I'm going to walk over to a larger 3D printed part where you can sort of see the lines more clearly. So this is like a vase, a pink and yellow vase, and you can sort of see these ridges here. So what we've done to make this part is actually taken basically a robotic hot glue gun. You've probably used a glue gun before, right? You have a piece of glue that gets molten, it gets melted by the heater inside, and you squeeze the trigger and it sort of slowly oozes out, and you can draw a line, right? So we actually have a robot glue gun, basically. So I'll take you back to the small machine and we'll peek inside. So this is the 3D printer that we use. And right here in the back is that glue gun. And if I maybe come in, you can sort of see where my finger is. That's the tip. This is off, by the way, so it's nice and cold. And it's a little nozzle with a hot, instead of glue, we're printing plastic. So we actually start with plastic that's right here. It sort of looks like a weed whacker line, doesn't it? That's actually plastic. And it gets carried from this spool into the machine and through that nozzle. So it comes out nice and soft. And you'll sort of see this rail, this hot glue gun, if you will, this extruder, we call it, slides back and forth in the X direction, we say, and then there's the Y direction. You talked about maybe Cartesian coordinates before, X, Y, and Z, three-dimensional space. So this machine can move its hot glue gun in the X and the Y to print a part. So it carefully moves it around and around to make one layer. And when that layer is done, it prints on an elevator. And that elevator moves in Z, up and down. So when it does one layer, it comes down, and then it prints the next layer, and the next layer, and the next layer, and the next layer. Or what about these gears that we 3D printed all at once, right? That would be a really challenging thing to carve out of metal or carve out of wood, right? But with a 3D printer, we can design it in the computer and print it one layer at a time and make it such that even all of these gears can turn all at once without us ever having to put it together. It comes out of the 3D printer just like this. But what we wanted to show you is that the printers that we have here and the ones that you have in your school are actually just small versions of the ones that the folks who make airplanes and cars and medical equipment, the things that they use. They actually use a machine like this. This is a big version. This is like the granddaddy of the things that you've just seen. This is a version of that, and you can sort of see it's in a giant oven. And I can open that oven and take a peek inside. It's really hot in here because we print really tough plastics, not just the plastic that I showed you, the weed whacker line that we call PLA, which is a neat plastic, but it's not very strong. But up here, you'll see it's the exact same kind of machine. We got the nozzles back here, and it's all insulated from the heat. And it moves again. You can sort of see it moves in Y, and it can move in X, and this elevator moves in Z. So it operates exactly the same way. It's just a beefier machine that can make stronger materials that we can actually use to make really advanced parts that could go on cars and airplanes.
What other materials can you print with a 3D printer?
Avery, that's my favorite question. So yeah, we talk a lot about 3D printers being used to print plastic, but we can print much more than that. So I just showed you copper. We can print something like this. This is aluminum, a really lightweight material. Let me turn my camera around if I can hit the right button for a change. There you go. So this is actually a printed aluminum brick, if you will, but it's really, see these crazy patterns? It's called a lattice. It's extraordinarily lightweight. I mean, I don't have to have any struggles to hold it up, but it actually is something you might like put in front of a Jeep and prevent it from getting a crash that could hurt everybody, right? It can absorb the impact really well. We can print titanium. Let me take you to a different room to show you that. We can print steels. We can print ceramics. So the kind of material that your bathroom sink is made out of. We can even print tissue, like living tissue. Well, not living, but tissue that you could implant into your body to help you regenerate bone or even muscle. So there's people thinking about, how do we 3D print an organ? Could I print, for example, a new kidney or liver to help people live longer and repair damaged organs? So I walked into a different room. This room has has 2 machines in it, and you can see they're much, much bigger. I'm going to open this one up. Let me turn the light on first. You'll see me hit the chamber light on. Oops. Then I'll hit this big safety button. It's off, so I'm allowed to do it. And inside, you'll see this white powder. You see that white powder? That's another type of plastic. It's then on a powder form. And this plastic is, it can be a nylon, or we print other really cool materials. But instead of extruding it from a hot glue gun, it actually, at the very top of the machine, you'll see we have a window. I'll stick my phone in there. That is a window that a laser beam comes through. And the laser beam shines on this powder, and wherever the laser touches, it melts that powder into a liquid, and then it cools down back to a solid. So the laser draws a pattern of the shape, the layer they want to do, and melts that layer, and then it comes in right here. We have this roller. This roller spreads, and it picks up powder over here and spreads it all the way across and provides a new layer. This is actually on a piston. So the piston lowers down one layer. And so then we spread powder across to create the new layer. And then we provide enough laser energy to melt the layer, but also melt it into the previous layer. I said something about, we can use this, for example, to help print models of images from CT scans to help doctors plan surgeries. So this is actually my head, believe it or not. Now my head it's not that empty, I don't think. It's not that small. But this is actually a model of my face. I went to the doctor to get a CT scan. And you see that little bone in the middle of my nose is a little crooked. Let's see if you can see it. Pretty crooked, right? Well, the doctor took a picture, and I actually took it to the lab, and we 3D printed and brought it back to the doctor so he could see exactly how crooked it was or how he could fix it.
How long does it take to make something?
That is a great question. Bailey asked the most important question. So is this as fast as the way we make other things? How long does it take? Well, the answer is it depends on the machine. So we have some machines, like these small machines. It probably takes, I would say, about an hour to grow a part, to add enough layers to get to a 1-inch tall part, which is sort of slow. Now, some of these more advanced machines that we have can go much faster, maybe 2 inches per hour. But we have other machines that print other ways that can get even taller or bigger parts even faster. And so that's really exciting. That's some of the things that we do in our lab, is try to speed up the machine so we can print faster parts better.
Can a 3D printer print just hard things, or can it print soft things too?
So this is a new machine. This machine's another ink jetting machine. It's moving back and forth. Let me turn my camera around. And you can sort of see it's printing a black and white shape, right? Well, it just so happens, and that it's a little fun star, and it says our lab name, Dreams. It has a hokey bird and a VT logo. So every time that machine's going back and forth, it's actually jetting, like raining little drops of plastic. And that plastic turns from liquid out of the nozzle to solid with that bright light. That's actually ultraviolet light. That's why we have this protective glass over it. And that protective glass keeps our eyes safe. But that light hardens that plastic. And the cool thing about that machine is that it can print hard things, like you asked. So this white material is really hard. This is a wheel design, but that black material is actually soft. It's really squishy. So we actually have a new project we're working on to actually print rubber. And we're wondering, could we maybe use 3D printing to fix worn tires so that we don't have to throw them away? Could we actually just print new tire tread on your tire? Wouldn't that be cool? So we never have to throw another tire away. That would be awesome. So there's lots of ways to do 3D print. It's not just with a hot glue gun. You use lasers, you use inkjet heads, you use ultraviolet light, you use powders. We can print titanium and ceramics and all different types of plastics, and even print really soft tissue? These are all excellent questions.
Which types of 3D printing technologies are there?
So we call them, there's lots of different machines out there in the world, but there are 7 types. There are only 7 types. So we've shown you a few. We showed you extrusion. We showed you binder jetting, where we're ink jetting powder, ink jetting glue into powder. We just showed you a thing called material jetting, another type of jetting, but this time we're jetting the material. These machines are called powder bed fusion, where we're using a laser to fuse together powder particles. There is the last 2 that we don't have in our lab. They're actually in different parts of the campus. One is called directed energy deposition. We're using a laser to melt wire, like a welding process. And the last one is called sheet lamination, where we take sheets of material and we sort of glue them together so they all stick together to make a big part.
Great. Thank you, Chris, for showing us your lab and all of your cool machines. And thank you, Miss Gibson's class, for showing up with all of your awesome questions.